Welcome to this video learning session. When you complete the session, you will be able to identify and analyze a project's critical path. In this session, you'll learn what a critical path is and why it is important, how to calculate task dates and identify the critical path, and how you can use Microsoft Project to analyze and display the critical path. A critical path is a series of tasks that must be completed on time. Any delay in a task on the critical path will delay the overall project. If a task that is not on the critical path is delayed, the project is not automatically delayed. Like the chain shown here, there is some slack built in. But a task on the critical path has no slack at all. In other sessions, you learned how to create a work breakdown structure and identify various task patterns. Now you will analyze task durations, calculate start and finish dates, and display the critical path. Start by creating a box with 5 sections: task name, task ID, task duration, start day or date, and finish day or date. Here's a tip. When you calculate the finish day or date, you must be very careful not to add too many days. The start day is the first day, so instead of adding the entire duration to the start day, you just add the remaining days. For example, if a task starts on day 10 and has a duration of 5 days, the finish is at the end of day 14, not day 15. Here's how it works. Day 11 is the second day. Day 12 is the third day. Day 13 is the fourth day. And day 14 is the fifth and last day. Let's try some calculations using dependent tasks. Task 1, prepare outline, starts on day 1 and has a duration of 5 days. So the finish is day 5, not day 6. Task 2, create document, can start on day 6. Task 2 has a duration of 9 days. So it will finish on day 14. Next, we'll try multiple successor tasks. Multiple successor tasks are like 2 dependent tasks instead of 1. Both successor tasks can start the day after the predecessor task ends. Task 1, develop plan, ends on day 30. So tasks 2 and 3 can start on day 31. Here's a multiple predecessor task pattern. Task 3, conduct interviews, cannot start until Task 1 and Task 2 are finished. Task 2 ends on day 5, but Task 1 does not end until day 15. Since Task 3 cannot begin until both predecessor tasks are done, Task 3 can't start until day 16. In other words, Task 3 must wait for the later of the 2 finish dates. Here is a simple 5-task example that uses all 3 task patterns. Task 1 starts on day 1 and has a duration of 10 days. So it finishes on day 10. Task 2 can start on day 11 and has a duration of 30 days. So what is the finish day? Right, day 40, not day 41. Now tasks 3 and 4 both can start on day 41. When will they finish? Task 3 has a duration of 5 days, so it will finish on day 45. Task 4 has a duration of 25 days, so it will finish on day 65. When will Task 5 begin? Task 5 can't start until the later task is done. Task 3 ends on day 45, but Task 4 continues until day 65. So Task 5 must wait until day 66. It has a duration of 30 days, so it ends on day 95. Now that we calculated the dates, what is the critical path? The critical path is a series of tasks with no slack time. Let's start with Task 1. Task 1 starts the project. If it slips, that will delay Task 2. So Task 1 is on the critical path. The same is true for Task 2 because it controls the start of Tasks 3 and 4. Task 3, however, has some slack time. It ends on day 45, but Task 5 doesn't start until day 66. So if Task 3 is delayed for a week or two, it would not delay the project. However, any delay in Task 4 will delay Task 5, so Task 4 is on the critical path. The critical path is Tasks 1, 2, 4, 5, because any delay automatically affects the overall project. In Part 3, you'll see how Microsoft Project analyzes and displays critical path information. Here's a work breakdown structure, complete with durations and predecessor tasks. This is how the same data looks when you enter it into Microsoft Project. When you enter the work breakdown structure, Project creates a Gantt chart, which is a horizontal bar chart showing the tasks and task patterns. A PERT chart, which Microsoft calls a network diagram, shows even more detail, including start and finish dates. This is a zoomed-out view of the entire project. The program lets you hide task details so you can focus on the patterns. The red line indicates the critical path. Now we'll zoom in to see the details. Notice the task names, task IDs, start and finish dates, and durations. In this session, you learned what a critical path is and why it is important, how to calculate task dates and identify the critical path, and how you can use Microsoft Project to analyze and display the critical path. For more information, you can refer to the textbook or your student study tool. Now it's your turn to apply your skills and check your work. For background information, tasks to complete, and sample answers, go to the Management Information Systems CourseMate at www.cengagebrain.com. Select this text and navigate to the video learning sessions. Thanks for attending this video learning session.